Hi, this is the notes for the geometry portion. Remember, this is not going to be emphasized on the test, although it is in Alex, and I want to make sure that you have something to refer to. All right, so we did talk about the other formulas in class. I'm going to go down to the geometry rectangle area formula. So remember, it's just, length times width. Squares, you can use a separate formula for them, but you don't have to because each side length is the same, so you could call it s squared. It's really just length times width. It's just length and width happen to be the same if it's a square. The triangle area formula, and this is the top of page 2, the triangle area formula is 1/2 base times height. Essentially, it's half of a rectangle. So this is the one that looks most like half of a rectangle. And this is a right angle here. And the base is going to be the one that is perpendicular to the height. So the base is going to be this piece. And then the height is going to be this piece. Now the height is not always one of the side lengths, and that's why I've got the 3 pictures here, because in these other ones, it is not one of the side lengths of the triangle. So in this one, if I have the base be this side, then the perpendicular that goes to that side from the opposite vertex is going to be that. So it is not one of the side lengths, so you would need to have some additional information other than just side lengths in order to find the area if the triangle looks like that. There's something similar that happens with this one, and this one can sometimes throw people off because the altitude actually, or height, falls outside of the triangle. So we extend over here the side of the base, but we don't make it any longer than where it is. It's still just this piece for when we put it into our formula, but we just kind of extend it out here so we can see that if we drop that perpendicular, it would create that right angle with the height, and then you would use that height value to get to the area. All right. Next section, looking at circles. Circumference and area. So, pi, hopefully that's a familiar thing there. So it is irrational. It's one of the kind of most famous irrational numbers. And we use that because it is something that the Greeks found when they would measure around the outside of a circle and then measure across. And whenever they did that, they got pi. So that's how they got the circumference formula, because they were just taking actual measures of around the circle, dividing them by across the circle, and they always got that number pi. Now the diameter is all the way across, and you can use that in the circumference formula, but the radius is only halfway across. And you can use that either in the other form of the circumference formula or in the area formula. Notice that the area formula, you can only use the radius. So one of the tricks that people sometimes have trouble with in these problems is they forget this fact and they try to find the area with the diameter or vice versa. So make sure that you know which piece you're given. And I would recommend just figuring out, if I've got the diameter, figure out that radius right away. Just cut it in half. If you know the radius, figure out that diameter right away by doubling it. And then you have both pieces available, and make sure that you are substituting them properly into the formulas. Frequently, they're going to have you use 3.14 for pi, and make sure that you are rounding to the specific place past the decimal point. That can make your answer come up wrong, even if you did everything else right. All right, volume and surface area. So if we look at the volume of a rectangular solid, pardon me, is essentially the extension of the area of a rectangle. So instead of just length times width, we now have that third dimension of height. So we're going to multiply by that as well. And for the surface area, if you think about any little box that you might have, and let me see here if I've got, oh, here I've got one. Okay, here my little timer is about the size of a box. Okay, so if I'm thinking about this, there's the opposite sides are congruent. They are the same. So this side is opposite this side. The back is going to have the same dimensions as the front. So if I think about surface area, essentially what I need to do is figure out one of each of these rectangles and then double them. So that's where that formula is coming from. So there's the length times width, which is the top and the bottom. There's two of those. Height times width is going to be the front face and the back face. And then L times H is going to be the left and right faces. So just two of each of those. With a cylinder, which is essentially a prism, we just have interesting names for all of the circle stuff, it seems. You are going to want to find the radius. And then you're going to need the height. The height being that perpendicular distance between the two circles. So it has those two circular faces. We're just going to measure in between those. So if I look like at this cylinder that holds little clips for me here. So I want to find the radius is going to be halfway across here. And then the height is going to be, what is this distance between the one circle face and the other circle face? So that is the height. And with those two pieces of information, you can find both the volume and the surface area. One way to think about the surface area is if you had to wrap it with paper, but you didn't want to use any more than necessary, you can think about the surface area of a cylinder as a really big rectangle with two of those circle bases on it. And that's where this formula comes from. So this is 2 times the area of the base, and this is, here is the circumference times the height, which is essentially length times width for that big rectangle. So this is because around the circle would be 2 pi r. That's that. It's also there. And then the height, the distance between the two circles. And then using the radius to find the area is pi r squared. So you get those two pieces that come up there. I find sometimes if I know why the formula is written the way it is, that it's easier to remember because I can think through what is happening there. All right, so moving on to page 3, we get the volume of a sphere, and spheres only have one dimension that we are concerned about, and that's going to be that radius. So we are going to find whatever that radius is, and then we will plug it into these formulas. So the 4/3 pi r cubed, and then the surface area is 4 pi r squared. To do the 4/3 in your calculator, just make sure that you are including everything. So like 4 divided by 3 times pi, or 3.14, whichever is being used, times your radius raised to the 3rd power. And then that will come out fine. Otherwise, another way to think about it is you could do 4 times pi times r cubed and then divide by 3. Either way will work. Those two expressions mean the same thing, so they will allow your calculator to correctly follow order of operations. So once you find the radius, my friends who were engineers in college, you just plug and chug. So you put the numbers in there and go to your calculator to figure out what you're going to get. There's not necessarily anything with this on here, but I just wanted to talk about in the general case of the volume of a prism, and it's very similar to what I was talking about with the cylinder. So you're going to have those two bases, and then that are the same, and then a height. And so for the volume, you just figure out the area of the base and you multiply it by the height. So if you think about a deck of cards or a roll of quarters, think of each of those layers as the base, and then you're going to multiply it by how tall it is. So if I have several coins there, if I find the area of one coin, and then I can just multiply it by the height there. So of course, coins would be a cylinder, so that would be that previous formula. But if you have other things like, I don't know what there are candles and things like that that are in different polynomial shapes there. So you just figure out one layer and then multiply by the height. And then the surface area, very similar to the cylinder on the previous page. So you're going to have the two bases, right? Area of the base to cover those. And then you've got a rectangle that is essentially, those three sides of that triangular base. So it would be something like that. So you're just figuring out the area of that big rectangle where the perimeter of the base is that unit. And then this one would be your height. Now, a couple other specific cases, well, especially the volume of a cube. So, as I was saying with the area formula of a rectangle, it's just length times width. So, but if you had a cube, it would be sides squared because the sides are the same. Well, volume of a cube, same thing. So instead of saying length times width times height, we're going to say S times S times S because every one of these dimensions is equal to S. And then if you think about a die, a single dice, then you can think about we've got a top and a bottom, a left and a right, a front and a back, but they all happen to be the same. They are all S times S to get the area of those. So there's 6 faces. Each one is S times S, so 6S squared for the surface area. And last one here, volume of a cone. So you're going to have radius is going to be an important measure. And then our height. So similar, this is the 3-dimensional version of the situation with a triangle area formula. So we're looking at the height, which is going to be the perpendicular distance between the vertex of the cone and the circle base of the cone. So just figuring out volume for that is the area of the base times the height, but then we only take 1/3 of it because it's pointy. If it was just a straight up and down like a cylinder, then we wouldn't have the 1/3 on there. But that's the relationship between cones and cylinders. If they have the same size base, and same base and same height, then the volume of the cone is 1/3 the volume of the cylinder. Pardon me. And you can do the same thing in your calculator. So you can do 1 times pi times r squared times h, and then divide by 3, or you don't even have to put the 1 times 1 in there, because of course we know that's just not going to change anything because it's the multiplicative identity. All right, I'm going to pause this one and then I will do a couple with examples in the next video.